Okay, this is number 17. So I'm going to sketch this rational function. I'm going to find a few important pieces of information before I find the derivative. So first I'm going to find the x-intercepts by setting y equal to 0. Okay, when I set y equal to 0, put this over 1, cross multiply, I get 0 equals x squared minus 6x plus 12. We're looking for the factors of 12 that give us negative 6. So if you go through your list, you should see that you can't find any. So we're going to go into using the quadratic formula to try to solve this. So I'll put negative 6 in the b spot. A is 1. C is 12. And then if you evaluate this, you get 36 minus 48, which is negative. So I don't even have to go any further because this is negative. I know that I'm going to have only imaginary answers. So this has no real x-intercepts. All right, keep going. Now I need my y-intercepts. So I'm going to make x equal to 0. So I have 12 on the top and negative 4 on the bottom, which means my x-intercept is negative 3. I'm sorry, y-intercept. All right, so I could plot that. So negative 3 is down here. All right, now I'm going to find my vertical asymptote. So that's by taking the bottom and setting it equal to 0, the bottom of the original guy. So I get x equals 4. All right, so now I'm going to go to my graph, and I'm going to plot 4. X equals 4 is a vertical line. All right, now I'm going to look for my horizontal. The top degree is 1 bigger than the bottom, so that means that there are no horizontal asymptotes, but there is a slant. Slant we find by using synthetic division. So 1, negative 6, 12. 1, negative 6, 12. And then 4 on the outside because it's not the factor, it's the 0. 1 comes down. 1 times 4 is 4. Negative 2, I'm adding. Negative 2 times 4 is negative 8. Add, I get my remainder, my constant, and my x. So my slant is y equals x minus 2. All right, so that tells me to start at negative 2 because it's minus 2. And then up 1 over 1. Up 1 over 1. And down 1 over 1. Okay, there's my slant. All right, so now I need critical values. So to find the critical values, I need my first derivative. Okay, the derivative of the top is 2x minus 6, and the derivative of the bottom is 1. So I have this times this. So x minus 4 times 2x minus 6 minus 1 times that. All right, so now I have to multiply this out. So I have 2x squared minus 6x minus 8x plus 24. Okay, so I have 2x squared, these combine, negative 14x plus 24. All right, and now I have to subtract this. I'm just going to put it underneath it just because I'm running out of a little room, and I can line up my terms anyway that way. So I have negative x squared plus 6x minus 12. So this is 1x squared. This is negative 8x, and this is plus 12. All right, so that's the top. So the first derivative is x squared minus 8x plus 12 over the bottom squared. Bottom squared. All right, so to find my critical values, I'm now going to set this equal to 0. Put this over 1. Cross multiply, I get 0 equals x squared minus 8x plus 12. All right, so now I have to factor that. So let me just move it over. I need more room. X squared minus 8x plus 12. Okay, factors of 12 that give me, what am I looking for? Negative 8. So I have x minus 2 and x minus 6. So my critical values are 2 and 6. All right, so now I'm going to split up my number line. So splitting up my number line, I'm going to use, get more paper here. This problem is long. There we go. So 2 is an important number, 6 is an important number, and then I also had my undefined value in the very beginning of 4. All right, so we're testing from negative infinity to 2, 2 to 4, and 4 to 6 into the first derivative. The first derivative is, gotta go back now, transfer it over. X squared minus 8x plus 12 over x plus 4 squared. Or actually, it's x minus 4, sorry. All right. I'll pick 0 here. 0 squared minus 8 times 0 plus 12 over 0 minus 4 squared. Positive over positive is positive, which means that this section of the graph is increasing. Okay, now remember 2 was one of my critical values, so this is where I'm going to look to see if I have a relative minimum or maximum. All right, so 2 to 4, I'll use 3. 3 squared minus 8 times 3 plus 12 over 3 minus 4 squared. Okay, the bottom is positive because the whole entire thing is squared. They have 9 minus 24 plus 12 is negative, so it's negative over positive, negative, which means the whole thing is decreasing. All right, 4 to 6, I'll choose 5. 4 was the undefined value, so I'm not going to have a relative minimum or maximum here. Okay, the bottom is positive. I have 25 minus 40 plus 12, so negative over positive, which means that the whole thing is negative, so it's decreasing. All right, I have one more interval I forgot to put here. I have to test 6 to infinity. All right, so 6 to infinity, I'll use 10. 10 squared minus 8 times 10 plus 12 over 10 minus 4 squared. Bottom is positive. 100 minus 80 plus 12, that's positive over positive. So the whole thing is positive, which means that I'm increasing. All right, this was my undefined. This is where my vertical asymptote is. This is going from increasing to decreasing, which means that I have a relative maximum. This is going from decreasing to increasing, which means that I have a relative minimum. Okay, so I need to find those actual points. So I have to go back to the original function, which is x squared minus 6x plus 12 over x minus 4. Okay, and we have to plug in 2 and 6. All right, 2 squared minus 6 times 2 plus 12 over 2 minus 4. All right, so we have on the top 4 minus 12 plus 12 over negative 2. So 4 over negative 2 is negative 2. So my relative maximum is 2 comma negative 2. All right, now I have to plug in 6. All right, when I plug in 6, I have 36 minus 36 plus 12. So I have 12 over 2, which is 6. So my relative minimum is 6 comma 6. All right, so now I got to plot those. So I have 2, negative 2, and I have 6, 6. All right, and now I'm going to look at the behavior of the graph. So from negative infinity up to 2, here's 2, my graph is increasing. And from 2 to 4, it's decreasing. And from 4 to 6, it's decreasing. And from 6 to infinity, it's increasing. And there's the graph of my function.